All right, guys. So further testing with the boiler jet. Um, so I want to show you some where I'm at with this development. All right, so this here is the standard jet that we've is pretty much what we've been using for like 4 years. With some, the only changes have really been how we inputted the water. The last revision basically we were um, inserting a tube into the very end and then drilling holes into one of these caps, one of these hex caps, and injecting the water directly in this way and hoping that air would carry the water in and atomize it in that process. And that worked. However, once we started doing this is doing that much better, especially now because if water is carried in through the drip hole inside the jet, it is atomizing. It actually kind of coats the top of the nozzle, and then it trickles down the walls and coats the nozzle pretty good. So, and that's really the whole point of this. So it's doing that, plus it's injecting steam already. You know, it's already converting the water to steam pre-processed, so it's going to make that more efficient because the bonds are already becoming weakened for the reaction process to take place for the carbon to basically the carbon steals the oxygen out of the water molecule and forms CO, and then the hydrogen is left free. All right, so this has been working, and then as you can see, there's no degradation here. So, and that was been an issue with this longer jet. The original versions, they had a much shorter jet, and we didn't really have any degradation at all with the shorter jets. But once I started extending them in further into the reactor, is when I started noticing these the nozzle was degrading. So so hopefully now with this new nozzle we can go in farther. And well, actually the goal of going in farther, the problem with having the short jet is the fuel would be biased to the front of the machine. So you'd have you'd conclude the run and you'd have all this fuel at the back of the machine, and you know it's usable fuel. So the idea of going in with this longer jet is to get the reaction process further deeper into the machine, so that as fuel is consumed, it's more centered, and then you should get a longer, more, you know, you're gonna have more available fuel per hopper load. If this proves to be too long, all I gotta do is whack the end of this off and re-weld it, so it's not a big deal. So I did go in a bit long. This may be too long, so I may have to shorten it. Maybe I got it right. I don't know. We're gonna test this and find out. So, and this is sort of a pre-production version. This is all stainless steel. And that's something else that we'll be introducing for the 2025 model year. I've seen enough with this. This is going to be the jet we're going to use for the 2025 models. So, but because we're introducing stainless, so we're going to be we're going to have a weld set up. So I've decided to make a few additional changes. The side brackets on the side of the machine will be made of stainless. The lid will be stainless. The flare cup is going to be stainless. And I believe that's it. As far as the gas fire core, that doesn't need to be stainless. There's never oxygen in there to degrade it, so it's not needed. It's not necessary. And if we were to do this out of stainless, you'd plan on paying at least double the price. And the machines are already beyond what the market price point perception is anyway. So I don't want to be raising the pricing. So yeah, to keep costs low, we need to you know, only build things out of stainless that are absolutely necessary. Otherwise, there's no need. That gas fire will last you a lifetime. All right, so I'm gonna get this installed in the machine, and we're gonna go out there and do another test run. In the last video, the machine actually consumed 5 liters of water per 10 gallons of charcoal. And I did get a weight. I thought my fuel was about a pound per gallon. This fuel is oak charcoal, so it does weigh a little more than the charcoal that I originally weighed, where I got the 1 pound per gallon. So this charcoal actually weighs 10 gallons weighs roughly just over 15 pounds, about 15 and a half pounds. So I'm gonna have to recalculate some of my numbers, but I mean, still, I mean, five liters of water per run, that's phenomenal. It's crazy good. So it's a pretty big breakthrough. So we're definitely going to this new nozzle design. All right, so I'm gonna get out there, get this installed, and then we're gonna do another run. Alright, so we're out at the machine, you know, and I skipped right over the main reason why we're going to stock the sheet metal is the water tank. The water tank is the main reason that we're going to stock the stainless, because that'll be done in stainless from now on. So there won't be any corrosion or anything like that causing flow issues that we've been experiencing with this. If you have a steel one, I suggest putting a pickup tube in the threaded end of the needle valve, and that'll prevent things what settles in the bottom of the tank from getting in the needle valve. That seems to have solved the issue on this one. And then I actually got this idea from another client, so and it's been working for him. He used I think he said he used a pen. Stuffed the end of a pen into the nozzle, or the needle valve where it threads into the tank. All right, so I'm gonna go ahead and get this fired up. Okay, so now, because that nozzle extends so deep into the machine, when you first fire it up, that, you know, the ignition needs to migrate to basically the end of that nozzle, so that the air coming in through the nozzle can take over the combustion process. So I may be too short. May have to let it go a little further. Okay, so I can see ambers through the nozzle, so it should be good now. up and running. There's really nothing more to really show. But, you know, at least I've done it, do this in one take, and I've done it over and over and over again. You know, guys that are cutting the video after they clear the machine, they're generally having, the reason they're cutting the video is because they're having problems. You shouldn't have to cut the video. You should be able to do it all in one take. You're being deceived. But I do got a little bit of a leak, so I'm gonna fix that. I just need to put another zip tie in that hose. But I got the valve cracked a half open, and ooh, too much. Pretty dim. So I'm gonna let this get good and warmed up before I really crack that open anymore. You see I got the check valve on here now. Look how far that valve's open. My mixer valve, way past 50% open. Of course, I don't have a load on it, but I'll do that here in a minute. I gotta readjust the inverter. I got it set up for gasoline, so this isn't gonna pull 60 amps. So I'm gonna have to reduce that down. But anyways, we're gonna let this run and see how much water we can consume with this new jet. Then see if it's consuming it more centered. So we'll come back. Alright guys, so coming up on the end of the run here. Alright, so I'm gonna go ahead and shut this off. I should have got the cap from go ahead and shut my water drip off. So actually about a quarter turn seemed to be ideal, and it did go through the full tank, and I literally filled it up with a hose all the way to the spout. So it's a little over 5 liters. And then, if you notice, I've added this vent hose. There's a tube that goes inside up to the very top. So as water in the tank heats up, if it comes to a boil, it can vent, and then we're not going to waste that. So that's going to vent right into the nozzle. All right, so when I started the run, it was 4 o'clock, and it's about 10 to 7, and as you probably may note, the shadows on the ground, so we're well into the evening. So it's it ran 2 hours and 50 minutes, consumed a full tank of water. So I'm gonna take a look inside that hopper. Get my glove on. So again, we're gonna show this. You always want to open the hopper and stand back. Woo. Yep, and I burnt some hair on my arm. Yeah, I wouldn't normally do it like that, but I'm holding a camera. But that's what it looks like. So it didn't bias to the front, and you can see it's right there in the center. This is where our combustion zone is. So I'm gonna go ahead and shut that. So so it can cool down. So I'm pretty happy with that. Okay, so when I started the run, I had an even 2 kilowatt load, and it sustained that for the first 2 hours, so from 4 o'clock to 6 o'clock. And then it just wouldn't sustain it anymore. But I am at the end of the charge on my batteries. So as you know, or may know, when you're running a charger, especially the chargers on the inverters, the voltage will creep up. I mean, that's how it knows when the batteries are full, right? So as that voltage is rising, so is your overall watts. So what you're setting in the inverter is your amperage, not the wattage. So yeah, just wouldn't sustain more than 2 kilowatts. So I had to throttle the amperage down, and ended up about 1400 watts for the last hour, or last 50 minutes or so. But that's still you know, a good run. You know, you just gotta take what the machine will give you. You know, it's not about pushing this thing to the edge. It's about getting it to run stable and hands-free. You know, at the end of the day, it's about what the kilowatt hours are after the run. So you wanna get the most you can out of it, but not to the point where you're constantly fiddling with it. Just you want to keep it running. You want that generator running at a stable RPM where it's supposed to be running. So if you're not able to do that, you gotta reduce the load. Just take what the machine will give you. So yeah, I'm pretty happy with that. We're gonna continue doing more runs to test this nozzle, to test to make sure it's not degrading. But the beauty of this nozzle is, if it does eventually degrade, all you do is pop it out and, you know, grind the crud off the end and re-weld it. You know, that nozzle will last for pretty much forever. I mean, it's not gonna degrade you know, every week or something, you know, to where it's whittled down to nothing. You know, it's gonna last, you know, a good long time. So anyways, I'm gonna conclude this video. So far this is a success. So we'll see you in the next one.